Hi everyone, today we're solving problem 29. In this problem, we're supposed to consider the integer combinations a raised to b for a between 2 and 5 and b between 2 and 5. And here they've calculated them out for us. If they're then placed in numerical order with any repeats removed, we get the following sequence of 15 distinct terms. And they've given out all of these numbers in numerical order with the duplicate removed. How many distinct terms are in the sequence generated by a raised to b for 2 less than or equal to a less than or equal to 100 and 2 less than or equal to b less than or equal to 100? So this problem is actually really easy to brute force in Scala. All we're going to do is iterate over all values of a, all values of b, and then distinct out all of these a raised to b combinations. So let's go over and switch over to IntelliJ. So first I'm going to create a val all. This represents all of the possible combinations. So we're going to do a for comprehension of a in 2 to 100 and b in that same range. And then for each of these we're going to yield. And here, when we're raising a to the b power, we're going to sometimes run into really large powers, and we can't fit them into an int or a long. For example, 100 raised to the 100 is going to be huge. So we're going to use big ints here. So I'm going to create a big int of a, and I'm going to use the bigint.pow method, which takes the exponent of type int and gives a big integer, which represents the original big integer raised to the b power. So now I have all I have to do now is println all dot distinct dot size. So we're gonna use distinct, which gets us all with the duplicates removed, and we're doing dot size to get the size of this. Now we can go ahead and run this. And we get our answer, 9183. So that was pretty easy to implement, but if we notice, this algorithm is n squared if a and b are in the same range. Just to try things out, let's see what happens when we change 100 to 1000. And we're seeing here that just multiplying these two upper bounds by 10 made the program much slower. So only now did we finally get the answer. I have implemented a faster solution for this problem that runs in big O of n time. So solving this problem for an upper bound like 1000 is no big deal for it. I have the solution up on GitHub, so feel free to take a look at it, but the math behind that solution is quite involved. So I'll probably come back to this problem in the future to explain how the faster solution works.